we have Kelly Lum joining us next, aka Aloria, to dox her Twitter, which she's not doxing because it's public. But hopefully she's in the room. She's in the room.
Yeah.
Wonderful.
Good afternoon.
So, Kelly, if you've got a deck you want to share?
Yep. I guess I'll just share my whole screen.
Fantastic. And what will happen is we'll shut up when you're ready.
All right.
So, welcome, Kelly, Aloria.
Thank you.
So we think you've got quite a different perspective, which is in the title of the talk here. So without further ado, we'll shut up and hand it over to yourself. Thank you.
All right. Yeah, whenever you want to start, I guess. Ooh.
You go.
We're good.
Oh, we're good.
We're good.
So the participants can see my screen, I assume.
Yep.
Okay. Yeah.
Yeah.
This is a new, like, the breakout room thing in Zoom is a new piece of functionality. Pretty awesome though. Anyway, so hi, my name is Kelly, also known as Aloria, on the internet for some reason. And so this presentation is entitled Mo Code, Mo Problems, a Slapdash approach to code scanning. I will not be using this talk to get into a debate about the pros and cons of various code scanners. There are a zillion of them out there. They all equally kind of suck and also are equally kind of great at various degrees of what you would consider great or bad. So let's get into it. Right, how do I, oh, there's my mouse, 2 screens, very difficult. So this is the obligatory introduction slide about why you would care about anything I have to say. So I am the director of security somewhere for a company that you probably never heard of, that services companies that you probably use quite often. But this talk has nothing to do with my employer. This is something that I have found challenges in my own private research, as well as multiple companies I've worked for that want to do code scanning for either compliance reasons, or for me, my own personal, I'm lazy and I don't want to read code. Please let me find the low-hanging fruit, and so I can rabbit hole that way. I've been working officially in InfoSec, meaning that somebody cut me a paycheck since 2003. El hombre del sombrero me envió mi contras muchas historias asombrosas. A man with a hat sent me, told me very interesting stories. I don't know why I put that in there. Anywho, so here's the problem. Let's say you want to scan a lot of things. Let's say you want to scan a lot of code bases for whatever reason. So for example, if you're doing personal research, maybe you just want to like cast a wide net and see what stuff you can find in those code bases. Maybe there are a handful of maybe competing applications that you're interested in, and you want to find the one that is going to be the least problematic in terms of code quality. Code scanners can not only help you find vulnerabilities in code, but they can also help you find buggy code, inefficient code. So, maybe you have 4 or 5 things that kind of do the same kind of functionality, but you're not really sure which one to pick. And as a security or a, productivity-minded person, you want to find the one that makes you the most comfortable using it. The other problem is that when you're evaluating multiple different code bases, they are usually in a lot of different languages. Obviously, building the code is always a little bit different, depending on the language, but also depending on the different build steps. So for this, just for this presentation, I've decided to go with the one that I found the most pain in the ass, which is .NET. I have a long and storied history, love-hate relationship with .NET. So these are some of the ones that I've chosen to scan. And we'll get into a little bit about why some code building processes can be quite difficult. So, we have, I already said this, but we have so much code, multiple languages, you need to run different commands. They may have different steps in building. So for example, I have project A, and all you need to do is do like make build or whatever. For .NET, you may need to restore some packages, or this is probably true of Java, but Java and I don't talk to each other anymore. I've gone no contact with Java. The other problem is that, scanning as well as builds take a long time to run generally. And the larger your code base and the larger the complexity that you have is going to make both of those steps very time consuming. So, you have the tiny little, I don't know, like 10 lines of code, bash script, probably not even worth running a code scanner on, but for a small project you would have issues with figuring out how to scan it. For a larger I'm sorry, I just completely lost my train of thought. For a larger project, not only do you have to figure out how to scan it, it's going to take a lot of time, and it is, if you want to scan a lot of things, or at least, more than, 2 or 3 things, you want to probably find an efficient way to do that rather than, sometimes it's a great excuse. I remember that, not that I'm a fan of XKCD, but they're like, why are you guys, fighting with swords? And, oh, we're waiting for our code to compile. Sometimes you just want to get it done efficiently. And this is very true in a work environment. So this slide talks more to the work environment that we're going through than applies to your personal stuff. I mean, with your personal stuff, you probably, can set it and forget it and come back and look at the results later. But what if you are trying to do this in a, for somewhere that you work, or, maybe you're just a part of an open source project that you want to contribute to. So one of the questions when I started figuring out how to automate this for my specific usage of running it locally is like, well, why don't you just put the scanner in your continuous integration and continuous development pipeline? Why don't you use what the company is using to build their projects? Anyway, like they need to, I'm sorry, it's continuous deploy, not continuous development. But why don't you just use, what they're using to build and release their projects? Well, first you got to find the people who own that pipeline to implement scanning. The other thing is, like I said before, adding scan steps will slow down the build servers usually. And anything that you do that slows down your builds, slows down any work, is going to lead to angry developers, which is obviously like understandable, right? Like we're all working really hard. We all have deadlines that we need to meet. We're all just kind of, anything that kind of throws, a wrench in the gears is going to piss me off, and it's certainly going to piss developers off. And the same kind of thing is, why not just, take your scanner and build it, add it as a plugin, or, link it somehow with the IDE. Not every developer uses one. I write my own code for a lot of security work stuff. and I use either Sublime Text or Vim. Not every scanner has compatibility or an IDE plugin. And, most people don't want their laptop to suddenly become a space heater or sound like a jet going off. And the other thing is that both of these steps require collaboration or participation by the individuals who are writing the code. You have to convince them that this is something that is meaningful and is valuable and it is worth their time to accept. And how can you do that when you yourself have not evaluated the scanning tool? Like I said before, a lot of scanning tools are varying levels of suckage and varying levels of awesomeness. So since I want to, before I go to a developer or go to the CI/CD team and say, yo, this tool is awesome, I should have facts to back that up. And I should see how painful that tool is. So if you need to evaluate a lot of different scanners, find the right one, whether it be a scanner that's free. So the example I'm going to use in this presentation is SonarQube, or the scanner that maybe you're actually going to have to shell out some money for. So, do I really, you got to justify to the people who are going to, actually write the check and pay the company, saying like, you need to usually provide verifiable results. I mean, maybe some places they're like, oh yeah, Kelly said that's cool. Yeah, let's buy it. And then they're like, oh yeah, the scanner actually mines Bitcoin, and now we're all fucked. Pardon my French. Okay. And I don't think this is going to take 30 minutes because it's a relatively simple topic, but we'll see. The solution. So I wrote 2 little Python scripts, relatively little Python scripts, to basically evaluate various code scanning tools. One, I wanted to see what the quality of the results were. So, is this going to just produce a lot of crap that I have to sort through and filter through? Maybe some of the results are useful, but then I need to come up with a strategy to, let's say, triage the results, throw out the stuff that sucks, throw out the stuff that, keep the stuff that's useful. Also, I want to evaluate whether this is something that I can reasonably ask people to use, whether it be in their IDE or their CI/CD pipeline. And that's a combination of, is this going to slow stuff down so that people can't get work done in a timely fashion, and just get frustrated and totally hate me and send me glitter bombs or flaming poop bags or I don't know. And also, are these results just going to completely confuse them, which creates more work for me or creates more work for the security team, because they're come back, they're totally freaked out because it's like, SonarQube gave me a grade and my grade is F. What does that mean? Like, I thought I was doing a good job. And it's like, well, yeah, you probably are doing a good job, but SonarQube has a couple of weird ways of, ranking things. So, for example, SonarQube will compare the last scan to the current scan. And if you introduced a certain level, a certain threshold of new problems, it will lower your score depending on what kind of problems you're basically introducing in that new scan. So again, I'm just focusing, just for the sake of time, maybe that was a bad idea, because again, I said I don't think this is actually going to take 30 minutes. I apologize for I did not provide enough beef. So this is just the example of SonarQube. Like, some scanners, you basically point them to a folder where all your scan lives, or you point them to a GitHub repository, and it just scans it. With SonarQube, it actually tries to be a little bit more intelligent than that, where they, in most cases, there is actually a counterexample to this that we'll get into, what they'll actually do is when you build your code, then it'll basically spy on your code build, see what is actually, what is being pulled, when and where, and sort of just kind of create like oh, okay, so I see, especially when you're rebuilding code, this is where it becomes like very helpful, because it's like, oh, I see they're only, touching these files, they're not touching these files, so I don't need to scan the whole thing. I just need to look at the stuff that's changed. So that's good for efficiency, as well as, knowing what to target when they do the actual processing of the scan results. So SonarQube, the way that SonarQube works, I should have put a network diagram in here. Hindsight is always 2020, or as the French call it, l'escalier, which means staircase wit, where you remember a funny joke after you've left the party. You need to start the scanner. So you'll have your SonarQube where you keep all your scan results on some sort of server or a virtual machine running on your desktop if you're just doing it locally. So you need to know where to send those results. So when you start the scanner, you need to tell it where the results need to be sent, and you need a key to authenticate to it so it knows that you're not just some sort of rando sending what looks like SonarQube results there. So they use the API key to authenticate, and if the API key is valid, then they will allow you to upload results. The other thing that I should have put in here that I forgot is that you're also going to need a consistent product name, and this is important if you're going to be doing incremental scans. So not just like one baseline scan and then you're done and you don't care anymore, but let's say, I have my code base, let's call it, I don't know, Taco City, and then I add more code to Taco City and rescan it, then it can actually do comparisons about how the code base is getting better or worse. And that's the sort of like letter grade example that I was talking about previously. So after that, you run the build. SonarQube, again, recommends that you, after the first time you build it, you run it as a rebuild, not a complete build. But either way, it will look and see. And I should probably pause at this moment and say I'm not getting paid by SonarQube to advocate for their software. I have mixed feelings about SonarQube, as I'm sure anybody who's ever used it does. So this is just for example's sake, because this is one of the more complicated code scanners that I've had to interact with. I'm sure other things like Baracode are probably also require a lot of steps, but this is because SonarQube does have a free community edition. I thought this would be a little bit more practical. But anyway, so then you run the build, and it depends on what you're building. So for example, if I am just, some things don't have to be built, like a Python script. You just run it, right? Like I guess you could post compile it. I know that you can do that for other interpreted languages. But if you're using something like, let's say, .NET, you need to, maybe upgrade your packages. You need to find the solution file. Sometimes things will have multiple solution files, and basically build it. For C or C++, then you're going to have to compile it using, GCC or whatever you're using. But again, if you're processing things in a lot of different languages, then you need to have different steps. So rather than manually sitting at the keyboard typing out all those commands, this is why I built Frankencode and Monster Mash. This is just, this is a coincidence that all of these things are sort of Halloween themed. I actually built these maybe like a year ago, and have been working on them since. But yes, nice timing there, Kelly. I'm patting myself on the back. Okay, so after your build runs, you need to initiate processing, and this is where the results will be generated. So so SonarQube is going to scan, spy on all of the stuff you're doing to build your code, and then collect the information that it needs to actually, evaluate the results of that build. So what it's going to do, or what it does, is it will pull down from your SonarQube server. And again, I apologize for not having a screenshot of this, because some of the stuff I have redacted a lot of content here. It's going to pull down your rule sets. You know, there may be rules that you have disabled because you really don't care about them. There may be rules that you have found to be not applied to a particular code base or a particular thing that you're looking for. And, you know, again, it's just way too noisy. There may be things that you basically, maybe you want everything. Maybe you want a specific amount of things. Maybe you want a mix of the two. So it'll actually say, oh, okay, what are the rules that I need to actually run against the build, and then generate the results and upload them. I'm going to actually interject one additional thought here, is that if you are running SonarQube somewhere, I mean, you have to run the SonarQube server somewhere. If you are running it on a very, very large code base, one of the largest code bases that I've run SonarQube on is more than 1 million and less than 10 million lines of code. And if basically send the local run of SonarQube, the local scan actually will try to send it in like one entire HTTP post to the server. So make sure that, like, whether you're running Nginx or whatever for your web server, for the SonarQube server, make sure you increase the size of the amount of packets it accepts to the maximum value that you think that server can handle. Because, yeah, it's a lot. It's like, I'm just going to throw you this whole car. Not like, here's a, nope. Yeah, that was a bad analogy. I apologize. It's early. So let's take a look at this code. And I will show you what I've done here. So hopefully you can all still see my, and again, this is not the, I know that there are some people who do Python like quite a bit, and this is not the most Pythonic code. This is not the cleanest code. Again, I wrote this just so I could get stuff done, not to have the most beautiful, elegant solution possible, because for my purposes, this was more for proving that this scanner was something that I actually wanted to impose upon developers, you know, like basically demonstrate that it was worth the pain that they would be experiencing. And I think that's really important for any security professional, not just with code scanners. Just to do my brief, like 10-second TED talk, is you really get a lot more receptive when developers get the sense that you're not there to play like mall cop riding around on your little motor scooter. And you're like, yeah, I know this sucks, but you know, it's important, and it's really going to lead to, you know, you having to do less work in the future. And the analogy I always use is like, when I make a meal in the kitchen, I always wipe down the counters afterwards rather than letting it build up and do like one big clean at the end of the week. It's just like a lot easier. You know, you're not getting in there with the gasoline and the what are they called, magic erasers, and like putting in a lot of elbow grease. You just wipe off the stove every time you cook. Anywho, so as you can see here, this is where I'm passing in, and this is not a real API key because, you know, I like to not tell people where my actual stuff lives. If you want, this is base64 encoded. If you want to find the Easter egg there, you probably want to screenshot that real quick. And this is the location of the SonarQube server. There is, if you try to go to this URL, you will not get anything. Probably should have just like posted like a quick, like, you know, joke page at this subdomain, but yeah, again, hindsight's 2020. For this one, I'm actually accepting two different commands. So this one scans .NET Core, and also it scans things that are just not .NET at all. So for example, some things will be PowerShell scripts. Some things will be, are they PowerShell? No, some things will be, like some things will be Python scripts. Some things will be other compiled languages. I think I had some PHP crap in there at one point. And then I just list out the projects that I want to scan. Again, I have reacted the name of the projects that I actually did. And then I define the start command, because if you're scanning .NET Core, you need a different command than for scanning interpreted languages. And then I say, here's the build command. So it's just straight up .NET build. And then the end command is actually what initializes the post-processing and says, hey, I'm done building. Please analyze my stuff and send it to the SonarQube server where the results will be stored. Now for the other, so the not .NET stuff, I list my projects. One thing I forgot to mention is that, let me see if I can find it. Yeah, so here, so some of the things that I have are like basically mixed content. So some of them had like C or C++ code. So these and also there was one that had Objective-C too. But these, sorry, I didn't mean to say you. These need to be run by a different scanner. And right at this point, I didn't care about those. But either way, I could not scan C or C++ because SonarQube requires that if something should be compiled, then it will refuse to do anything with it if you're running the one for interpreted languages, which is Sonar Scanner. Now, again, there's no build command, so I'm not doing any build. Then I have this weird thing here. Basically, this is every if you actually do like code analysis, this is probably a little piece. I'm sorry, I should have put a content warning here. You have basically a bunch of nestled ifs. So I go through every project. I first say, okay, assuming that it will fail, I say, hey, fail starting SonarQube. That would fail if it cannot get access to the server, if there is a problem also with the server's TLS certificate. So like if there's a certificate mismatch or whatever, then SonarQube is not going to be happy with you. I believe it refuses to talk to the SonarQube server if it's not over an encrypted connection. So then I am just doing, I'm creating the start command. So basically saying, start the command, and then this is the project. Then I run the command. So now I have assumed that the SonarQube start has happened. So now I'm going to say failed build because the build might fail. And my run command, where's my run command? Oh, it's right here. So run command is just doing a subprocess in Python. It is essentially running the command that I throw to it. If there is an error, then I can get it using this, basically process communicate. I can get the status, and then I can return that status so that I can say, here's what messed up. Here's the error that I got from running this, from attempting to run this command. So then I attempt the build, and if that runs, then I start the post-processing. Again, just putting this as an error in case post-processing fails. The one time, there are a few reasons why post-processing fails. I already mentioned one where the SonarQube server can't accept the large payload that you're sending it. The other one is maybe just the server is down. Maybe your computer lost internet access or whatever. Maybe you need to send it over a VPN. Your VPN connection is not there. And then if that actually succeeds, then it's success. And at the end, I will give the results basically saying, you know, nuggets, success, attendees fail, and here's where it failed. Here's the step in this process where it failed. And then I can also put an error message if I want to. I did not do this here. There is one thing that you can add if you want to get the full output. So if you actually, I did this just because I didn't want to see like stuff scrolling over and over again in my PowerShell window, which is where I will run it because I'm an insane person. But you can actually add stout subprocess pipe into here. Or actually, no, I'm sorry, you could take this out if you want the full output. Right now, I'm basically saying I just want the stuff that I'm printing out here. Let me just make sure I'm okay on time. Okay, cool. And then it's basically the same thing for Monster Mash. I broke this out because this is .NET Framework, not .NET Core. And so not only do you need to know the name of the project, and again, this is the name of the project that's inside in SonarQube. The name of the, if you do not have that project already set up and you scan the same code base, but you give it a different project name, it's going to automatically create that new project name with the scan results, and you won't get the advantage of having incremental builds where you can contrast differences between versions. The other thing about .NET Framework is sometimes you'll have a bunch of different solution files, and there would be a master solution file that runs all of the other ones, essentially, just kind of simplifying it a little bit. So then I basically say, because MS Build doesn't, if there are multiple solution files, MS Build doesn't know which one to use, then you need to basically specify it. Again, I am going to talk to SonarQube. Again, see here that I'm using sonarscanner.msbuild rather than .NET Sonar Scanner, because they're different commands, because they're different languages, essentially. And then I have my end commands. And basically, I'm doing the exact same thing in the other one, but in addition to adding the name of the project, I'm also adding, I'm appending the project key to the command for the build. And then same thing happens. It lets me know which one screwed up. And then hopefully my results will be in Sonar Scanner. And let's get back to the thing. Cool. So I know that time is a little short here. I forgot when I was supposed to end, but I will see if anybody has any questions. Again, I'm sorry that I couldn't show you the actual server or you know, the stuff actually running, just because this is heavily redacted for reasons I will not disclose.
For reasons, no problem. And it's an age-old problem, isn't it? Dealing with security or AppSec in pre-production environments,
Mm-hmm.
and any tool to do the job is sometimes the appropriate approach.
Yeah.
So it's fascinating stuff, and coverage. You talked about your between 1 and 10 million lines of code. You know, there are many examples of this, and how you achieve the coverage is the challenge, really. We do have one question. Sean, would you mind reading that out, because you can probably see it a little bit better than me? From Nikos.
That one.
I'm not reading that one.
Oh, a question I have is that there's a lot of rules in SonarQube that can be tweaked, meaning that a score won't hold everywhere. How to deal with potentially uneven evaluation standards when it comes to providing assurances that X code is good code. So basically, rules can be modified.
Mm-hmm.
How do you ensure those metrics around those rules are consistent across the organization?
So the great thing about I shouldn't say great, but one of the helpful features of SonarQube is that you can actually create rules that are specific to a portfolio. So you create a portfolio and you put all of your all the things you're scanning, all your projects under that portfolio. So you can make sure that, and then you apply your rule set to that portfolio so that basically everything is being held to the same standard. If you have different standards for, you know, different things, basically like, hey, this is mission critical stuff, I need to be a little bit more hard-assed about it. Again, apologize my language. I don't think anybody gives a fuck, but you know, I'm a New Yorker, we curse. But you know, like, so like say this is mission critical. We need to like have all the rules, and you know, because our auditors are going to get pissed off if they find out we disabled it, or you know, this stuff, okay, this stuff is experimental. We mostly just care about, you know, best practices and you know, making sure that there aren't any bugs that would, you know, make it not perform well. You know, you can make a separate portfolio for that. So hopefully I'm understanding and answering the question accurately. But yeah, so you can apply different rule sets to either different portfolios or different projects, but if you want them to be consistent, then, you know, just lump everything that you need to be consistent around the same thing into the same portfolio. The other thing that I would say is I recommend, and probably do this on a smaller code base to start with, is just running it with the full gamut of rules, just like all of them. And, you know, just carefully going through and looking at the ones that you find valuable. If there is somebody that you need to justify, you know, why something is valuable or not valuable, then I would, you know, just like make like a Google Doc or you know, some notes somewhere, basically saying we disabled this rule because of X reason. We kept this rule. This rule should never be disabled, for example, of Y reason. And, you know, have that documentation out there. One, because, you know, if you get hit by a bus, you don't want somebody ringing your cell phone while you're, you know, in hospital. But also because, you know, people will come back and say, oh, wait, but you turned this rule off, and, you know, like, you can just turn off whatever you want, and, you know, make your results, you know, look better than what it actually is. So, you know, have that. Obviously everybody should be documenting everything, but it also comes back, and so you can say, hey, yeah, I turned these off. I had these people agree that it's okay to turn them off, and you know, I'm not trying to do anything shady here.
Hey,
Yep.
but when I turn all the rules off, nothing.
Yeah,
alone.
exactly.
It's great. It's great. I get no problems.
Yeah,
It's
just like-
great.
All right, Kelly. Yeah, no, that's fantastic. Okay, we've run out of time, but thank you ever so much for your time, sharing your wisdom on a very important topic. So, thank you very
Yeah,
much.
thanks everybody.
Thank
Thank you.
Cheers.